Okay, so today in Algebra we are in Chapter 9, Section 3. We're going to look at some special products of polynomials. Special products. We're looking for patterns, as we kind of started to do yesterday. The first pattern is called the square of a binomial pattern. And the square of a binomial, what would you expect to see? You would expect a square, so she's saying like an exponent of 2, and what would you be squaring?
A number.
Maddie?
Whatever binomial is inside the parentheses.
Good. Okay, so a binomial. So here it is in the form of a rule. We have a plus b, a binomial, and like you thought, it would be squared. So we learned the acronym for a binomial times a binomial yesterday. What is the acronym? FOIL. Good. So go ahead and do that. FOIL it. Expand this out. We have what happening as a factor twice, Lauren?
A plus B
Times.
A plus B.
Good. A plus b times a plus b. So when we FOIL this, the first term, a times a, gives us, good, a squared. The second term, or the outside, a times b gives us,
B squared.
a times b gives us ab, right? And then the inside terms, b times a gives us ba, which is the same as ab, isn't it? So we have ab happening twice, don't we? And then the last terms give us b times b or
B squared.
b squared. So are there any like terms here, Jack? ab, how many do we have? 2. So we could say a squared, good, plus 2ab plus b squared. This is called a perfect square trinomial. So right now we're learning how to deal with factors, multiplying factors together. So we call this the squaring of a binomial. It gives you a different pattern called a perfect square trinomial. So this is a little preview. When you look at a perfect square trinomial, there are how many terms? 3. That's trinomial, the definition, right? And notice the first and last term are both squared, okay? But there's always something in the middle. And the middle is 2 times a and b, okay? So we're going to be delving into that pattern soon too. Okay, so we could go straight from a plus b squared equals the final expression that we just wrote. That's what we want to do. We don't want to go through FOILing something that we are going to commonly square, and that's a binomial. If you needed to, you could FOIL. The goal is that you look at a plus b squared, that quantity squared equals a squared plus 2ab plus b squared, and you can go straight there. Now, what do you think the common error is? Sad face down here. We're going to put the common error in the box. Summer. A plus b squared equals what?
Maybe they said instead of 2ab, they said ab squared.
No. Common error. Arthur?
A squared plus
B squared.
Good job. Good job. It's a squared plus b squared. Okay? I skipped over one little thing here, another expression, but this is just such a common mistake for somebody to say a plus b quantity squared is a squared plus b squared. And I wish that, you know, I could say that it will never happen to the class of 2013, but it'll happen probably tonight. And tomorrow I'm going to have it on the quiz, and it may happen then. Little homework quiz, okay? So if this is a mistake, then what would be the equivalent mistake of the second term here? A squared minus b squared. That would be a mistake. So instead, let's do the proper thing and let's write what does a minus b, that quantity squared, equal? So if you need to FOIL it, FOIL it. But what do you think you will have when you have a minus b squared? Well, the first terms would be just exactly like what you saw up here, right? The only difference now is we would change one of these signs, or both of these signs, to the opposite, right? So the first terms, do we have still a squared? A times a is a squared. And now a times negative b is what? Negative ab. And negative b times a is negative ab again, right? And so we have two negative ABs, right? Negative 2AB. And then negative B times B, negative B is?
GB.
So notice the first and last terms are both just squared, positive. A squared and B squared. But in the center, because there was subtraction in this binomial, we have negative 2AB. Okay, so let's be careful as you give me the value of the quantity 2x plus 5 squared. Before you even write it, can you tell me what it isn't right now?
It's not.
It's not, Talia, you say it.
It's not 2x squared plus 5x squared.
It's not, 2x times 2x would be
4x squared.
4x squared
plus
5
squared.
5 squared is what?
25.
25. So the answer is not 4x squared plus 25. That would be the number one mistake. Okay? And in the second one here, the answer is not what? 9x squared plus y squared. It's not that. You can't just square each term like that. You have to either FOIL it or use the pattern, right? Okay, so for A, if you can remember the pattern, which is brand new for you today, so it's going to take a moment. A plus B squared equals the first term squared. The last term squared is on the end, right? But in the middle, we have 2 times AB. So let's apply that here. The first term squared here is 4x squared. Don't forget to square the coefficient too, okay? The last term squared is 25. We already said that. And now, what is A times B? What is 2x times 5? 10x times 2. 20x is your middle, okay? And you can find that, again, by FOILing it if you forget the pattern or you haven't learned the pattern yet. 4x squared, I have 10x, 10 more x, there's my 20x, and 5 times 5 is 25, okay? Okay, let's try it with this next one. Now the only difference here is we have A minus B. So the first term squared, the last term squared, but what is the middle term? I hear it, Dina. 2AB. Okay? So let's use the pattern to create this trinomial. What is 3x squared?
9x.
Good job. 9x squared. And what is negative y squared? Positive y squared, isn't it? Negative y times negative y is positive y squared. Okay, and in the middle, we have 3x times negative y. What is that? Negative 3xy times 2, which is? Negative 6xy. Good. And so let's see that again. If we were to expand this and FOIL it, we would have, first, 9x squared, right? We would have 3x times negative y, which is negative 3xy, and we have it again. Negative 3xy is negative 6xy. Good. And then negative y times negative y is y squared, positive. Okay? Okay, I think it helps to look at it both ways, but ultimately the goal would be to go straight from the binomial that's being squared straight down to the trinomial, right? Remembering there is a middle term. Okay? So go ahead and pause the video, come back and see if your answers are correct. Okay, so you might want to pause the video and check out the answers here. In the first two, these students used the pattern and didn't show any foiling. And then 3, we have a visual of the foiling, if you weren't just using the pattern that we learned. And 4, you kind of see that as well. Okay. Okay, the second pattern is my more favorite pattern. I love this pattern. Probably because we start with a 2-term, 2 binomials, and we bring it down to a smaller looking expression. Okay, it's called the sum and difference pattern. And so the sum and difference pattern means that we're going to see what operation. Sum represents what operation? Addition and difference, subtraction. We're going to see addition and subtraction. So we're going to see a binomial with addition and a binomial with subtraction. So there it is, a plus b times a minus b. So go ahead and FOIL it and tell me what you get. Okay, so when we FOIL it, the first term, a times a, gives us what? A squared, good. How about a times negative b? What does that give you? Negative ab, right? And then what about b times a? Positive ab. So I have a negative ab and a positive ab. What is that? They're opposites, right? Good. And then we have b times negative b, which is negative b squared. Good. So here's what it looks like expanded, but notice those outside, inside are opposites. So we end up eliminating those and getting straight to this smaller expression. We end up with the difference. This expression here has a special name. It's called the difference of two perfect squares, which totally makes sense. It's a difference of two squared things, okay? And we're going to see that when we start factoring. We're going to start with this and end up back at these factors, the sum and difference, okay? So, very important. It's the difference of two perfect squares. Okay, so the sum and difference pattern give us the difference of two perfect squares. You could FOIL it to find it, or you might just see the pattern and say, oh, I know what that is. Okay? That's the goal. So, let's try A and B here. So let's go ahead and FOIL so we can see this again. And when we do, Selena, what do we get? Three times negative. Negative 9. Okay, so we see opposites, and so we end up with what when we simplify? Do we see here the difference of two perfect squared numbers, right? 9 is a perfect square, r is a perfect square. So ultimately the goal would be to come straight here. Okay? Let's see if we can go straight there with this one. So the outside and inside terms are going to cancel. So we simply need to say, what is, what are the first terms? 16x squared, good. And what are the last? Negative y squared. The outside and inside cancel. 4xy, negative 4xy, boom. And you may FOIL it to see it. If you don't feel like you have a connection with these patterns, do more FOILing. And then you're going to say, oh, I don't need to see those middle terms anymore. I can go straight to the reduced form. Okay? It's good. So go ahead and try these. Come back and check your... Okay, very good. We have some excellent answers to show you. Number 6, brought to you by Tara, and number 7, brought to you by Jocelyn. Good job. Any questions? Okay. This is interesting. Whoops. Let me do this. Let me pause for a second. Okay, so you might have seen a quick preview of this, but you can use what we just learned about the sum and difference pattern to do some special multiplication, special products using mental math. It's really cool. So when we look at 18 and 22, they are both equally far from which number? From 20. So we could write 18 as 20 minus what? 2. And we could write, so 18 is 20 minus 2, and 22 is what? 20 plus 2. And here's our sum and difference pattern. Oh. So all we have to do is square the first term. What's 20 times 20? 400. And subtract squaring the last term, which is what? And the answer is?
Whoa,
396.
That's so cool.
Isn't that fun? Okay, so see if you can do that. Whoops, see if you can do that here. What is 56 times 44? 56 times 44 would be 50.
6 minus 6.
It would be 50 plus 6 times 50 minus 6. So now these squares, 50 times 50 is simply 5 times 5 with 2 zeros, right? So 5 times 5 with 2 zeros is? 2,500 minus what?
Minus 36.
Minus 36. You can do that in your head. What is 2500 minus 36?
He knows.